Hi students, welcome back. Good morning. Today we are going to start a new lesson, states of matter. Okay. So in states of matter, we are going to discuss about intermolecular forces. Okay. So let us start the lesson now. Okay. I'll tell you the difference between intermolecular forces and intramolecular forces at first, okay? So forces, we are divided into two. The first one is called intermolecular forces, and the other one is called intramolecular forces, okay? Intramolecular forces. So intermolecular force, intramolecular means the force is within the molecule. Okay, the force within the molecule is called a intramolecular force. Okay, and intermolecular force means in between the molecule, the force existing in between the molecule. For example, if you take an example of iodine, okay, we can write it as I. This is iodine, right? So if you are taking this molecule, there's two types of force. The force this existing between the molecule, within the molecule, that is covalent bond, right? And the force between the molecule, that is, if you take the molecule of iodine, you can see in between these molecule, there are forces existing, and that is called an intermolecular force. Okay, so this is the difference between intermolecular force and intramolecular force. Intramolecular force is within the molecule, so covalent bond, ionic bond, all that one, metallic bond, all that is existing in intermolecular, that is intramolecular force. Intermolecular force is a force that will exist between the molecule. Okay, always intermolecular force will be weaker than the intramolecular force. Intramolecular force will be always stronger. Okay, so now let us discuss about intermolecular and intramolecular. So intramolecular force, if you take three types, we already discussed. What are them? The covalent bond, okay, and ionic bond and metallic bond. All these are coming under which force? Intramolecular force. Now, today in this section, we are going to discuss about intermolecular forces. Okay, intermolecular forces. Okay, what are the forces? This intermolecular force is also called van der Waals forces. Okay, so, and what are the different type of intermolecular force that we are going to discuss? So the first one is called Lenten force. Lenten force or dispersion force, okay? And the next one we are going to discuss is, that is also called dipole-dipole interaction. Dipole-dipole interaction. And the third type of force that we are going to discuss is dipole-induced dipole interaction. Okay, dipole-induced dipole interaction. The fourth type, that is called a hydrogen bond. Okay, so we are going to discuss about four type: Lenten force or dispersive force, dipole-dipole interaction, dipole-induced dipole, and hydrogen bond. Okay, so we can see we will met with the different cases. We met with a different type of force, that is ion dipole. So the ion dipole interaction or ion-ion interaction, all of these are not coming under intermolecular force. Okay. So now let us discuss the first case, that is Lenten force. So Lenten force, if you see how the Lenten force will exist, this is usually existing in non-polar molecule. Okay. Non-polar molecule like H2, Cl2, Br2, etc. This type of Lenten force is existing. Okay, so if you take such type of non-polar molecule, you can see that there will be we know that electron is continuously moving right around the nucleus. So if it is continuously moving, sometime instantaneously, the electron will be concentrating in one end of this molecule, and instantaneously it will develop a dipole. Okay. So instantaneously, you know what is for an instance only it will exist. That is why it is called instantaneous dipole. Because what is the reason? Because of the movement of the electron, sometime the electron density will be concentrating at one end of the molecule, and that will develop a dipole, and that dipole is called a instantaneous dipole. Okay, instantaneous. And this instantaneous dipole will introduce or induce a dipole in the adjacent molecule. Okay, so that is called a induced dipole. So momentarily it is developing an instantaneous dipole. When once this instantaneous dipole is developed, this will induce a dipole in the neighboring molecule, and that is called induced dipole, and that will result in an interaction. So there will be a charge. Dipole means there will be a charge separation between them. Okay, and because of that there will be an interaction between this molecule, and that type of interaction is called a London force or dispersive force. Okay, and it's that force is actually inversely proportional to what 1 by r raised to 6 it is, the distance between the molecule. Okay, centers of the molecule. Okay, it is inversely related to the 6th power of the distance between the centers. Okay, so that is all about London force, and this is the weakest intermolecular force. Weakest intermolecular force. Understand? This is existing in non-polar molecule, and this is the weakest intermolecular force. Okay, and all the molecule, this all the covalent molecule. Okay, simple molecular. So simple molecular structure, if you are taking like carbon dioxide, water, etc., which is having a covalent bond, all of this molecule, this London force is exist. Okay, next is about dipole-dipole interaction. Dipole-dipole interaction. So what is dipole-dipole interaction? It's very easy. If you see a polar, this is existing only in polar molecule. Okay, this is existing in polar molecule. So look at this. If 2 HCl is there, it is already polar because there is an electronegativity difference between Cl and H. So chlorine is more electronegative, and this is electropositive, and the shade pair of electron will be more dragging towards the chlorine atom, and so it is having a dipolar polarity because of this charge separation. And what will happen? It will induce it. This is also already existing as a dipole, right? No need to induce a dipole moment or a polarity in it. Already it is having it is a dipole. So there will be interaction between these dipoles, and that interaction is called a dipole-dipole interaction. Okay, so if you are taking a stationary molecule, you can see the force is actually inversely proportional to the 3rd power of a distance between the centers of this molecule. And if you take a molecule which is rotating, a cell molecule which is rotating, the force is proportional to 1 by 6th power of the centers of the molecule. Understand? So like that. Now, this is it is little bit stronger than that of London force. And if you take HCl, the different type of intermolecular force present is, we know that all the molecular London force is already present. So London force is also there, and dipole-dipole interaction. The 2 type of force will be existing inside that, so that it will be a bit stronger than that of the London molecule which is having the London force only. Okay. Now next one is called a dipole induced dipole. So in this case, what is happening is already there is a dipole. Suppose HCl is already a dipole, and this will induce a dipole in the adjacent non-polar molecule like Cl2, H2, etc. So it will induce a dipole, and so that it become plus and minus, and there will be an interaction between these molecules, and that interaction is called a dipole induced dipole. Here also the force is inversely proportional to 1 by R raised to 6. Okay, so these are the different type of interaction. Among all the intermolecular forces, the strongest one is the fourth one, that is called a hydrogen bond. We already discussed about this hydrogen bond. In hydrogen bond, how this will existing in, we know that there are some condition to exist hydrogen bond. Already we discussed this. And the first condition is it must contain the highly electronegative element like nitrogen, fluorine, and oxygen. Second condition, the atom must contain these atoms, nitrogen, fluorine. The electronegative atom must contain lone pair of electron. Okay, lone pair of electron. Okay, so if you take HF, there is what type of force, the hydrogen bond existing between HF molecule. What is the reason? Because F is highly electronegative, and adjacent to highly electronegative atom, there must be a hydrogen atom. So look at this, adjacent to the highly electronegative, there is a hydrogen atom, and so that there will be a charge separation already here, and it consists of lone pair of electron, and fluorine atom is highly electronegative also, and this lone pair will be donating to the adjacent hydrogen atom, okay, which is electron deficient. Understand? And that will result in the formation of a hydrogen bond. Okay, so this hydrogen bond we already discussed in the previous chapter. So I'm not going into detail, just understand the conditions. And this is the strongest bond, intermolecular force which is existing. So we know that in ice, which type of hydrogen bond is existing? Water hydrogen bond is existing. Alcohol is dissolving in water because alcohol will form hydrogen bond with the water. This all we discussed. Okay, alcohol will also carboxylic acid. Carboxylic acid is water soluble. What is the reason? Like CH3COH is water soluble because it will form hydrogen bond with water. Okay, so these are the reasons. Thank you. That's all for today. Thank you.